Now we are back in multistage compression. Multistage compression is basically discussed in your previous lecture video, in which already we discussed that multistage compression or multistage compressor. Actually, the compression process takes place in two stages. It may be two, it may be three, it may be four, like that. But it is basically compression or stage of the compression process takes place in number of one, greater than one. Okay. Now, as you know, the compression process that is basically done in your polytropic or isothermal or adiabatic, in which one of them, but is basically isothermal is most effective compression process if the compression process takes place in isothermally. Now, the most important point which we will discuss in the previous lecture, that compression process takes place in more than one cylinder. Now this is the block diagram. This is the block diagram in which you can see that there are two cylinders basically used. That is LP cylinder, means low pressure cylinder, and another is high pressure cylinder. Now in between low pressure cylinder and high pressure cylinder there is one intercooler are generally used. Okay, this is the intercooler in which cooling water is flowing in through the inlet port, and after circulating of cooling water through the pipe, that hot water is coming out from that portion of from that valve. Okay, now as you know that the piston cylinder assembly, the compression process takes place in which the air sucks. When the air sucks from the atmosphere, the pressure is P1. Now it sucks into the piston cylinder assembly, or you can see the low pressure cylinder in which the pistons can move up and down. There are another process also, there suction, compression, expansion, like that. And this is a D1, means S1 D1 means suction and discharge, suction valve, discharge valve 1. Now through D1, through discharge valve, the pressure will be delivered through the intercooler, in which intercooler function is that the temperature, as the compression process takes place in the low pressure cylinder, the temperature will be increased obviously. So temperature in that portion P2 and temperature will be T2. Now T1, that temperature will be T1, that temperature will be T2. Now T1 obviously greater than T2 greater than T1, as because of the compression process takes place. Now so T2 somehow reduce to reach T1. Now how do you do that? By using the intercooler. Intercooler basically heat exchanger in which the temperature of air is basically reduced. Now as the pressure introduced into the intercooler, the pressure will be introduced into the high pressure cylinder. That pressure will be in the suction portion, that will be introduced in your air compressor. Now in piston cylinder assembly, piston can move and up and down, through which the final delivery pressure, that is indicated as P3, which will be delivered to your air receiver. Now as the name suggests, P1 is your suction initial pressure, or you can suction pressure. Now P3 is your delivery pressure. P3 which delivery pressure which is actually received by air receiver. Now PT is your P2 actually intermediate pressure. Now this is P2. Now P2 is your intermediate pressure in between P1 and P3, because as you see your PV diagram, the P2 will be in between P1 and P3, because of P1 is your initial pressure and P3 is your delivery pressure. Now P2 will be intermediate pressure. Now P2 will be shown in your PV diagram. And one more point, that compression takes place more than one cylinder, already we have discussed, and what you see, that is obviously more than one, it may be two, it may be three, series of cylinder can be used. Now uses in places high pressure air required. Where the high pressure air is required, you can use multistage compression process. But there are some shortage or some disadvantage also are there, which we'll discuss in the next video. Now obviously it is supplied to the air receiver. Okay, now if you will see the PV diagram, of the, now this is the PV diagram corresponding process. As you see that the 1 to 2 dash. Now if the single stage compression process takes place, now if the compression process takes place in single stage compression, the process will be like that. So this is the suction, this is the compression, and this is the expansion or delivery. So what you see, that the area, the work done required for single stage compression process is that, as you know that this portion, so this portion will be your single stage compressor, work done required. Now when you're doing your multi-stage compression, that means As you know that the 2 is your intermediate pressure, so you P2 or P2 will be in between P1 and P3 in the range of P1 and P3. Now P2 is your intermediate. Now this is PV diagram. As you see, this is P1 is the initial pressure, P2 is your intermediate pressure, and P3 is your delivery pressure, as you know previously. Now when the compression process takes place in the multistage compression process, that is indicated as your diagram 1 to 2 dash. Now 2 dash to 2, 2 dash to 2, it suggests there are some intercooling process actually takes place in which the temperature is reduced and pressure is constant. That means in constant pressure cooling process occurs in your intercooler. It is suggest that from 2 dash to 2. Now again from 2 to 3, again compression process takes place in your high pressure cylinder. So this is your single low pressure cylinder in which 1 to 2, this is your 2 and this is your 2 dash. So P2, or you can say that P2 dash or T2 dash. Okay. Now this is your T2. The in 2 to 3, the high pressure compression process takes place, and then the air will be discharged or delivered. So P1 is your initial pressure, P3 is your delivery pressure, in which the delivery pressure actually in far high, and 2 is your intermediate pressure in which in between P1 and P3 obviously. Okay. Now as you see that there are some advantage, that savings in work input, battery balancing, and more volumetric efficiency, already we discussed on this, and high delivery pressure. So what you see, this is a PV diagram. From that diagram you can obviously get some idea that high delivery pressure will be achievable. Now disadvantage is that obviously more than one cylinder is used, is complicated and highly cost and continuous flow of cooling water. Okay. Now if you see in your TS diagram corresponding to PV diagram, as you see the TS diagram, what you see here, that 3 pressure, this is a TS diagram of multistage compression process in which there are 3 pressure line are there. This is your initial pressure, this is your intermediate pressure, this is your delivery pressure that you can reach after multistage compression process. Okay, fine. Now as you see, as you know that the compression process in ideal compression process takes place in your compressor, that is reversible adiabatic process, or you can say asentropic process. Now that process actually indicated as your 1 to 2 dash. Okay, in low pressure cylinder. Okay, now 2 dash to 2, what you see here, this is TS diagram. Corresponding to 2 dash, temperature is here T2 dash. Now corresponding to 2 point, the pressure will be, the temperature will be T2. So T2 is lower than T2 dash. That means intercooling is actually occurred here. So it's a constant pressure process and intercooler is actually worked. Okay. As you see the line, this is your constant temperature line. What you see here, P1, P2, sorry, T1, T2 and T3. Okay. T1, T2 and T3. So T1 is equal to T2. That means what? That means T1 is equal to T2. Means initial condition of the, or initial temperature of the air is equal to temperature of the air after compression in low pressure. After compression in low pressure cylinder, that two temperatures is equal. That means it's fully intercooling process. That means perfect intercooling. That means here it is occurs perfect intercooling because of T1 is equal to T2. Because of T1 here, T1 is equal to T2 because of in TS plot, that this is your constant temperature line. This, so T1 is equal to T2. When you reach, if all the higher temperature will reduce in intercooler, the intercooling process takes place in perfectly. That's why it is called perfect intercooling. So what is the condition for perfect intercooling? That it should be temperature of the air at the suction condition in the low pressure cylinder is equal to the temperature of the air, the temperature of the air of the when the compression process takes place in the low pressure cylinder. Both are equal. If it is not, if T1 not equal to T2, that means imperfect intercooling takes place. If T1 greater than T1 is equal to T2, that means perfect intercooling. If T1 not equal to T2, that means imperfect intercooling takes place. Now we are assuming that there is perfect intercooling takes place. That means what is the main objective of intercooler? That is actually work here. Okay. Now again from 2 to 3 another compression process takes place. Actually this compression process takes place in what? In high pressure cylinder. So 1 to 2 dash is your low pressure cylinder compression process takes place. 2 dash to 2 is your constant pressure process, cooling occurs in your intercooler, and 2 to 3 actually the compression process takes place in reversible adiabatic process in high pressure cylinder. So from this is your P1 line and this is your P3 line. So P1 is here, P3 is here. So P3 greater than P1, obviously, as you see, this is P3, this is P1, P3 greater than P1. That means P3 is your delivery pressure and P1 is your initial pressure. So delivery pressure obviously far better or far high compared to the low initial pressure of air in your compression process. Okay. Okay, thank you very much for listening me and watching me. Goodbye.